on your potato chips. Make sure your can top is open up after. Okay, and
I'm ready.
do not bite on apple. So this thought, on the shoulders of giants. It's co-authored by three of us. Wrong. We three think that we are somewhat more seasoned glass professionals. So we thought that it would be a good idea to give this kind of talk. Of this bunch, Charles Kirkin has spent much of his life as a scientist at Bell Labs. He worked on strength of optical fiber. After retirement, he joined Rutgers as adjunct professor. Over the 5 millennia, maybe 6 millennia, glass as a material has provided lots of products which have improved the quality of human living. And there are all these examples. Important part is, no doubt, the underlying science, engineering, technology, and art have been developed by individuals whose ingenuity and hard work has paved the way. We stand on the shoulders of these giants. And so, in this International Year of Glass, we celebrate those US-based pioneers. This is the National Day of Glass conference focused on North America. So we are going to be celebrating those US-based pioneers who are no longer among us, but whose legacy lives on. I'll present between 6 and 8, maybe even 8, or maybe 10, because now I've got lunchtime.
You're adding them as you go.
Yes, who? So, the list of glass scientists, I think that you could imagine Zach Ryson, and in parentheses I've given them what they are really noted for. And you see, Zach Ryson was a US resident. By the way, at the time he wrote this paper, he was not citizen, but he was US resident. So that's how I've included it. On atomic arrangements in glass, David Turnbull, we know he developed the kinetic theory of glass formation, most important aspect of glass formation theory. Phil Anderson, John Van Black, they sorted out the electronic conduction in disordered solids, particularly the chalcogenide glasses, and they got Nobel Prize for it. George Moray, phase equilibria in soda lime silicate glasses and other glass systems. In fact, George Moray's book, I will tell you a little later. I just gave you a I'm going to skip that. Arthur Quincy tool, AQ tool, known for that single fictive temperature concept of glass behavior through the glass transition range. Don Stuckey, we all know. Don Stuckey has been called legendary scientist. He's got 60 so patents. Glass ceramics was his key thing, and we all follow that. Austin Angel, strong fragile liquids concept, very important. Stan Ovchinsky, I don't know if you understand and realize this. He had 400 patents related to amorphous semiconductors. Okay. Gordon Scott Fulcher, it was being called glass hero. He developed that Fulcher equation, otherwise called VFT equation. Extremely important for most commercialized products. Industry essentially goes by the VFT calculation. Hopefully that will turn to tomorrow. Michael Owens, known for the automatic bottle making machine, referred to by Ludwig Dahlke earlier yesterday. William J. Woods, he was the design concept of the Corning ribbon machine. And that ribbon machine, 1926, it revolutionized the light bulb making. The actual mechanical engineer, however, was David Gray, but most of the credit actually is given to William Woods. Now, we also know Lawrence Hinch, Larry Hinch. I should say Larry Hinch.
Larry.
Yeah,
Larry.
not Lawrence. Larry Hinch, he is the inventor of the bioglass. Bert Warren did the XRD of glasses, which appended the random network theory of Zachariasen. Doug McKenzie, founder of the Journal of Non-Crystalline Solids. Okay. Then I can continue on saying that, hey, Redland single vector temperature concept challenge came from Redland, and that also again, really made a fundamental change in our thinking. Norbert Kreidel, in some ways he didn't really develop anything groundbreaking. Nonetheless, he is remembered fondly, affectionately, because he was also a mentor of Don Newman, Delbert Day, Peter Schultz, and this guy here, David Fry. Okay? Alfred R. Cooper, again, really did not develop much groundbreaking of stuff, but he was mentor to me. Robert Weeks, radiation effects on glass. Now there is one name we are forgetting, right, David? Which one? Robert Derivas. I'm sorry, he just reminded me this morning that I'm forgetting Robert Derivas. Robert Derivas did a lot of work on water in glass. Very fundamental. Okay? Now, in terms of all of these people, you really don't have to remember all those names and what they did. All you have to do is look up this book, wonderful book. Remember, always, remember, you must have 2 copies. One for your office, the other one for your spouse at home, so that you are always on the same page. Glass artists. I got these 4 names here. Of course, there are others. Louis Comfort Tiffany, John Lafarge, Frederick Carter, Howard Bentrey, and like I said, there are a couple of others you could name, but let's continue here. The first guy on my list, William Holder Zachariasen. Understand the pronunciation, Zachariasen. He was a Norwegian American physicist specializing in X-ray crystallography. Published his solo author paper at age 19 at the University of Oslo. And get this, he received his PhD soon after in physics, and his advisor was Victor Goldschmidt, known well for the Goldschmidt radii, ionic radii. Okay? And this is 1928 when he got his PhD. So he was barely 22 when he got doctorate degree. He became faculty member at the University of Chicago on their invitation. He published over 200 papers over a span of 55 years. Most of them were solo authors. Okay? All right. His 1932 publication, which is the Atomic Arrangements in Glass, is the single most influential paper in all of glass science in terms of thinking about the structure of glass. He is known for those Rule 1, Rule 2, Rule 3, Rule 4, Rule 5, which is, what is Rule 5?
Read your book.
No, that's not Rule 5 is, friends, there are only 4 rules.
I like my brother.
He became U.S. citizen in 1941. Well, that's what it says. There are only 4 rules. So, Willie Zacharias, thank you. I think he should be given a round of applause. And that's, I think that's me standing on the shoulder of these giants, right? My next one is George Washington Moray, G.W. Moray. George Washington Moray was a mineralogist and a pathologist. He received 1909 B.S. in chemistry from University of Minnesota, joined geophysical lab in Carnegie Institute, D.C. 1912, till his retirement. Okay. He was involved in glass-making projects for military equipment. His most important paper was the 1925 paper on the phase relationships in soda-lime silicate glasses. Most of you take the soda-lime silicate glass Ternary diagram, almost for granted. Well, this is the guy who actually drew that. Okay, worked on it, drew that. He gave lots of, descriptions about the melting behavior of glasses, the devitrification temperature. You look up his book, Properties of Glass, and although it's a little bit dated, of course, but it is still quite a decent book. He got, after his 1938 publication, it became so popular actually that Alfred University invited him a year later to give him, confer upon him, doctorate honoris causa, honorary doctorate degree. And George Moray Award of the Glass and Optical Materials Division of the American Ceramic Society is the most coveted award in the GOMD. And that's where your diagram is, just to refresh your memory. So, George Washington Moray. Third guy on my list is Stan Opshinsky. He had 400 patents. He was founder of Energy Conversion Devices, was a prolific inventor. Most of these semiconductor and dielectric behavior of the chalcogenide classes and the amorphous solids. He is the inventor of devices based on conduction switching from high conducting state to low conducting state. That's what it was all his doing. So these are actually used in a lot of things: batteries, solar cells, LCDs, fuel cells, phase change memories, you name it. They are called ovonics. And then I think that he was the leader how the computers got miniaturized. Okay? Most important thing, these days these computers are, little bitties. Throughout his life, now that's also important, he fought for social justice. Always for the minority groups. In 1999, Time magazine called him hero for the planet. He was a high school dropout. So, guys, we remember it. A technologist, Michael Joseph Owens. That's the inventor of the Owens bottle machine. He was born in West Virginia. Now, at age 9, he dropped out of school and joined father working in coal mines. But then, while working in coal mines, he sustained an injury to his eye. And as a result, he dropped that job and then went over to work for this company, Hobbs Rock Mines. It's not 1988. It's more like 1888. In Wheeling, Virginia. And that's where children made up about a quarter of the workforce. Then got a job in Toledo, and that's where he actually rose through the ranks and developed the bottle making machine. So this bottle making machine was invented in 1903. At the time, at peak level, look at this machine here. This ended up being a 30-ton monster. However, imagine what it did. It was making 30 to 35 bottles per minute. Beer, therefore, could be sold a lot less expensively. And it is said that Owens' bottle-making machine revolutionized, changed the world. Okay? Because it was so, the beverage industry got its jump. There is something else which it did. Something else which it did. Prior to making bottles by this bottle machine, these were all mouth blown in using molds. Do you know how many? People when they were children at times, when they were blowing these bottles, it affected their lungs, what they were ingesting over the years. And so it is said that he must have saved thousands of lives as a result of converting from this mouth-blown process over to an automatic machine, bottle-making machine. So, for that, guys, William James Woods. William James Woods is the inventor of ribbon machine. It was conceived in 1921. At that time, it was Corning Glass Works. It was brought into action in 1926, Wellsboro, Pennsylvania. Take Route 15 up, and you'll find Wellsboro. It produced at the time, it produced 300 light bulbs per minute. And that was fast enough. At its peak of development, it's been producing 2,000 bulbs a minute. And this was how Edison's light bulb invention, or lamp invention, actually became a household product, because the cost of the light bulb became much less. It just was not significant enough to worry about it. It was this William Woods, and he was assisted by David Edgerton Gray. There's a machine here. This machine, I don't know how many people have seen Corning ribbon machine. Fantastic. Whenever teaching at Alfred, I took the students to Wellsboro to look at this machine in performance. You would see that you would need, in fact, to steady your eyes to be able to see the bulb transporting from index to index. Very fast, very rapid. American Society of Mechanical Engineers landmark is a landmark number 81. And one of these machines is housed at the Henry Ford Museum in Dearborn. And another one is in Wellsboro Glass Museum in Wellsboro, Pennsylvania. Well, for that, William J. Woods. Okay. Oh, have another clap. There. Larry L. Hench. Larry L. Hench is a 1969 inventor of bioglass, otherwise called 45S5. It's a sodium calcium oxide phosphate P2O5 silica glass. It is a bioactive material, and there are stories, and there is stories in fact in the print, basically saying that Larry was actually having was on a bus ride from an Army medical branch after receiving some kind of award. And on this bus ride, there was a U.S. Army colonel sitting next to him. And he said, hey, you do all this, couldn't you make a glass material that would be, that would heal the bones or, actively join the bones? So that got Larry thinking. And he does have some statements of the sort that there were 3 coincidences by chance. Number 1, but the last one, he just happened to take this P2O5 glass system, and it worked the first time. There was no rejection otherwise known, for most other materials. When implanted, bioglass reacts with the surrounding fluid, and it forms hydroxyl carbonated ester, HCA, which promotes integration with the bone. Bioglass has commercial applications. I think you saw one given by Bob Lippitz. Is he around? Anyway, bone repairs, dental restorations, enamel healing toothpaste, and many of these are FDA approved. So this enamel healing toothpaste is that Sensodyne. He got his PhD from Ohio State, and professor at University of Florida soon thereafter. He had 800 publications, 30 books, 32 US patents. Of these 30 books, he also wrote Boeing, the Bionic Cat, a series of 6 books. He's had several international awards, National Academy of Engineering, World Academy of Ceramics. So, Larry Hench, thousands of lives have benefited from the use of this bioglass. So for that, it comes artist, Tiffany. Okay? Tiffany started out as a painter, became a glass artist around 1875. In 78, he joined Candace Wheeler, Samuel Coleman, and Lockwood to form this company, Lewis Comfort Tiffany and Associated American Artists. In 81, Tiffany did interior design for, by the way, Mark Twain's house. Also, he was commissioned to redecorate the White House in 1882, such that President Chester Alan Arthur could move into the White House. This was later on all removed by Roosevelt. I think maybe some of the artists or maybe Carol can tell us about another lunchtime. He became the design director for his father's company, But I think that you know Tiffany is known for his uniquely stained glass windows. Have you guys followed his work then? David?
Yeah, he calls me up.
He calls you. Out, he's a ghost now, you know. And Lance was that, you know, this he's fairly well known for. This is in Baltimore now. So that's Louis Comfort Tiffany. All right, before I get to my last one, I'm going to take the time to tell you about this. Folks, this is the commemorative edition book, which I'm trying to compile and publish. It is, here's the front cover. And you see the front cover, it's got 200-inch, Mount Palomar disc, which is in the Corning Museum of Glass. That disc, I purposely shown the thermal shock cracking. I really do think that that photograph or that disc itself is really a great representation of science, technology, art, and human and spirit all put in one. And that's what I have thought as right on top of the book as the commemorative edition. There are other items here, as you see, some pictures. The editorship is not quite done yet because we may need some help, some more help, because we need to get this thing out as fast as we can. So you'll look out for your email. Is that right, David?
That's right.
Okay. He says. The back cover. The back cover is, you know, again, series of the products that you're known for, or the sciences. Everything. So I think that this is designed quite well, but it can only be successful if you would kindly cooperate. So look at your emails, which have come from Sue LeBoux. It asks for, if you have made presentations, please submit, not the whole presentation. Condense it down to 8 slides, landscape, because I cannot give more space. You know, people have 56 slides, forget it. And if you are 45 or more and have been around 10 years or so in being a professor, do send in a 1-pager reflections. And all that is in the email, so I won't take the time. I think that I think this book could be a good presentation for the November session of the United Nations on this.
Sure.
Okay. This is what we have accomplished here. Okay, my last one. Howard Ben Trey, I mentioned that he, he attended Brooklyn College. He learned to blow glass, also to pour, but he worked with Dale Chuli, and that's where he learned the casting of the glass. Okay? And his mission really was trying to beautify American urban landscape. And I mentioned in the panel discussion yesterday, this is what exactly transpired. In fact, there is a Art Creek Plaza around here where he had initially commissioned soda lime silicate cast glasses, which had actually developed cracks. And I was called in, and that's how he had connected. So for the Boston Post Office Square project, which you see here, some of these fountains he created. These were done with my, he was the artist, and yours truly was the glass engineer. Okay? I actually am pretty proud of myself. So I got to tell you that if you are in Boston sometime, visit Boston, do go out to Post Office Square. I think it's called Norman Lowenthal Plaza. And just walk around that park, see the art. During summertime, on good days, sunny days, there are lots of people roaming around in that park, having lunch and sitting around talking love at times. Yes. So, in Howard Bentley's case, you will notice that I'm now walking along, okay? But for that, I think that this is it. Thank you so much.